Welcome to the optional lesson on difference quotient. This lesson is recommended for any student who plans on taking calculus in college. Let's start with a warm-up. Where we are going to find the slope. Remember, your formula for slope is rise over run. Go ahead and pause this video. Try the practice problems before you advance to the next slide. Now that you had an opportunity to remember, hopefully you remember the formula, that slope is rise over run, or change in y over change in x. So for these functions, for these points, we want to find the slope. So we're going to do change in y over change in x. Two-fifths is our final answer. For example 2, again, we're doing change in y over change in x. Now I did these in both orders. It does not matter which one we decide is y1 and y2, as long as we are consistent with our order in which we subtract. For this one, I did 6 minus 8. Therefore, I need to make sure I do -2 minus 3. This one I did -10 minus 4 divided by -1 over 0. Again, it doesn't matter which order or what we decide is y1 and y2, as long as we're consistent with the way we subtract and that we keep those the same. Let's do a second part of the warm-up. Again, this is going to be relevant today. Please take a second, pause this video, and multiply these together, making sure you account for all signs and simplifying. After you've completed, please replay the video and move on to the solutions page. So when combining like terms, we want to make sure we're multiplying all 4 parts together. So we want to do first, outer, inner, last, and then combine our 2 middle terms so that we get a quadratic. Now, I put x minus 5 on there twice, but how you will normally see this is x minus 5 squared. Remember that if something is squared, it means there's 2 of them. Y squared means y times y. So if we see x minus 5 squared, again, we have to remember that that's x minus 5 times x minus 5. So for that example, we would end up with x squared minus 5x minus 5x plus 25, or x squared minus 10x plus 25. Please remember not to square over a set of addition or subtraction, and we have to make sure we get that center term. Same with this one. Again, the way you guys are going to see it on the lesson today is x minus h squared. And you have to take a second to remember that that's x minus h minus x minus h. When we multiply together, we get x squared minus xh minus xh plus h squared. We combine those 2 center terms to get x squared minus 2xh plus h squared. On our lesson today, we're going to see not x minus h, but we're going to see x plus h squared often, and we're going to remember that that is x plus h times x plus h, and it's going to have a very similar pattern to our third example here, except for it's going to be a plus in the middle. So when you see x plus h squared, you can go right to x squared plus 2h x plus h squared. Again, that will show up many times on our lesson today. So today we're going to talk about the difference quotient. The difference quotient is a connection between calculus and pre-calculus. The definition of a difference quotient is the measure of the average rate of change of a function over an interval. In this case, over an interval of length h. H is going to be a very small interval, so we can be as accurate as possible. If we were in calculus, we would find this average rate of change many, many, many times, and then that would be what we could consider the overall average rate of change. The formula is given below. And again, you want to think about that very similarly to the slope formula. And that will be on the worksheet that is in Schoolology. It'll give you a diagram and a graph of what that actually looks like. Again, what we're doing is we're finding the slope of a function. So let's go through an example. Let's start with a linear function. So let's say my linear function is f of x equals 8x minus 9. And I'm going to find the difference quotient, which again should be the slope. So if we look at that linear function, we should be able to predict that the average rate of change, or the difference quotient, will give us 8. Your formula again is f of x plus h minus f of x over h. So in order to find the difference quotient, we have two parts to our numerator. We need to start by finding the first part of that numerator, which is f of x plus h. So just like with compositions, we are substituting in the x plus h where our x term was. Then we're going to simplify that by getting rid of those parentheses and using the distributive property. The second part of the numerator is just our original function of f of x, so I don't need to make any changes. H is just a variable, so we're going to keep that in our denominator. So in order to figure this out, our first step is to find f of x plus h. We completed that here. F of x is just our original function, and then h is a variable. So at this point, we have everything we need in order to calculate our difference quotient. So we're going to start by substituting in f of x plus h to the first part, which was that 8x plus 8h minus 9. From that, we're going to subtract f of x. Make sure you put f of x in parentheses so that you are subtracting the whole original function, and then divide the whole thing by h. At this point, we're going to distribute that negative all the way through the numerator. And remember, it's all divided by h. At this point, we have a lot that we can cancel out. Notice we have a positive 8x and a negative 8x. We have a negative 9 and a positive 9. It cancels out, leaving us only the 8h over h, which then reduces to 8. Now it makes sense because we know that the slope of this linear line from the get-go was 8, and when we applied the difference quotient, we were able to get an answer out of 8. Now this works really nice for us for linear functions, not quite as nice for quadratics. Again, let's start by remembering that formula for difference quotient, which is f of x plus h minus f of x, all divided by h. Again, we have to start by finding f of x plus h. So let's grab our our quadratic function, and I'm going to use x squared minus 8x plus 7. So for step 1, again, I need to find f of x plus h. So I'm going to take my original function, and everywhere I see an x, I'm going to replace that or substitute in x plus h. Now we had a question similar to this on the warm-up. Remember that x minus h squared implies that there are two of them, x plus h times x plus h. Meaning we have to make sure we multiply that all the way through. When we do and we simplify, we get x squared plus 2xh plus h squared. Then I'm going to distribute that negative 8 all the way through. From that, we can now apply our formula. So remember our formula. We need f of x plus h minus f of x, all divided by h. So we're going to take everything we just calculated for f of x and substitute that in for f of x plus h. From that, we want to subtract our original function of f of x. Again, make sure you put your whole original function in parentheses. And then we're going to divide the whole thing by h. Our next step along the path is going to be to distribute that negative all the way through the numerator. Remember, we're dividing the whole thing by h. Once all our parentheses are gone, we can start canceling stuff out. I see a positive x squared and a negative x squared. I see a negative 8x and a positive 8x. I see a plus 7 and a minus 7. When those cancel out, it leaves us with 2xh plus h squared minus 8h all over h. Now I notice everything in my numerator has an h in common. Allowing us to then cancel out the h in the top and the h in the bottom to reveal our final answer of 2x plus h minus 8, of which I like to write as 2x minus 8 plus h, just to kind of rearrange. Now, one important fact about the difference quotient is that your difference quotient will always be 1 power less than your original function. So since our original function was a quadratic, 1 power less will be linear. Again, that's why I like to write that as 2x minus 8. That h, remember, is a very small increment of space, so that h over time will become insignificant because it is such a small value. I have included a link for another YouTube video. This guy again goes through a couple more examples just to allow you guys the opportunity to see it and hear it another time. And then I've posted an assignment on Schoolology for you guys to practice. There is a diagram at the beginning of the Schoolology assignment which also shows this on a graph in terms of how and what you are finding when you're calculating your slope.